Hi there, so in this video we're going to be looking at ratios, rates, and proportions. A ratio is defined as a quotient of two quantities that have the same units. There are actually three ways to write a ratio. You can use a colon between your two numbers, so here would be the ratio of 5 to 2. You can actually use the word 2, 5 to 2, or you can also write it as a fraction, 5 over 2, okay? I typically will write them as fractions, okay, but you can use any of the three is acceptable. So here in example 1, in a class of 20 students, there are 3 left-handed students and 17 right-handed students. Part A wants us to write the ratio of left-handed students to right-handed students. So that's telling you then that my left-handed, get my pen going, my left-handed has to come first. Left-handed to right-handed. So I come back up to my problem here, and it told me that I had 3 left-handed to. I'm going to write my fraction bar. My number of right-handed students, 17. 3 to 17. And again, if you wrote 3 colon 17 or 3 to 17, any of those three representations would be okay. Excuse me. I'll let you try example B. Let's move on down to example 2. An NBA court's 50 feet wide and 94 feet long. Let's do part A here together. It wants the ratio of the width to the length, and it's telling me here to write it as a fraction in simplest form. So I want my width to come first. It tells me it's 50 feet wide to my length, 94 feet long. Hopefully you agree here, both of these numbers are even, so we know they can definitely be divided by 2. So divide them both by 2. 25, 94 divided by 2 will give you 47. Final answer. Again, it could be written as 25 colon 47, 25 to 47. I'll let you try part B on your own. Let's move on down to rates. A rate is a quotient of two quantities with different units. So ratios have the same units. Here with rates, they have different units. You'll want to be sure that you include your units with your answer. Excuse me. Let's try example 3. So in example 3, it says in a 6-hour span, 21 people were treated in the ER. They want us to find the rate of people treated per hour. Per is always a cue to divide, okay? So just keep that in mind. So I want here the number of people treated, and it told me here that 21 people were treated. So I'll put that up top. I'm even going to put a little, put a phrase behind it to let me indicate what am I talking about here. So I'm talking about 21 people. Per means to divide, and then hours on the bottom, 6 hours. And then I can put that in my calculator if I like, or maybe I'll reduce first by hand, and then we can talk about whether you would go to your calculator or you know already, or just know what that is. 21 and 6 both have a 3 in common, so if I divide them both by 3, 21 divided by 3 is 7, 6 divided by 3 is 2. So you have 7 over 2, so 7 people every 2 hours, or 7 divided by 2 is also 3.5, so 3.5 people per hour. Excuse me. All right, I'll let you try example 4 on your own. Let's flip it on over. Let's talk about a unit rate, or also known as a unit price. A unit price is always going to be represented by the price divided by the number of units that one buys. A common example that you'll see down below is example 5. And this might happen to you. You go to the grocery store, for example, and you're trying to figure out which is the better buy so that you get the most for your money, okay? So here we're saying that a store has a 12-ounce soda priced at 84 cents and a 16-ounce soda priced at $1, and we want to figure out which is the better buy. So remember, it's always the price divided by the units. So I have one way that I can buy it. It would be 84 cents for a 12-ounce soda. And then if I put that in my calculator and divide, you're going to find that lands you at 0.07, because we're talking about money, so you want to do the round into the nearest cent or 2 decimal places. So that'd be 7 cents per ounce. All right, now let's look at the other soda. The other soda, its price is $1 divided by how much you get, 16 ounces. 1 divided by 16, and rounded to the nearest cent, so 0.06, so 6 cents per ounce. So again, so now what we're seeing here then is that 6 cents obviously here is smaller. So this is my better deal. So we would say then that the 16-ounce soda is the better deal because it is a cheaper price per ounce than the 12-ounce soda. Okay, I'll let you try example 6. Again, you can check yourself by the solution key. And then let's focus down here on for proportions. And proportions are where we set two ratios or two rates equal to one another. We set them up like proportions. We put like units across from one another, and then we cross multiply to find our answer that we're looking for. I'm going to do example 7 and 9 here with you, and let you try example 8 and 9 and check 8 and 10 and check yourself by the solution key. So here in example 7, it says that approximately 7,500 tweets are sent every 10 seconds. And it says, at this rate, how many tweets are sent in 1 minute? So let's look at what we have here. It's telling us that 7,500 tweets. So I'm just going to, I think it's really helpful if you'll put the units behind it. I think that'll be really helpful in the setup of these. You can, 7,500 tweets are sent in 10 seconds. By setting it up like this, then what that tells me then is that over here on the right, then I've got to put tweets up top and seconds on the bottom. Okay. So then it wants to know how many tweets are sent then in 1 minute. So I don't know how many tweets, so I'm going to put an X up there. And then 1 minute, I can't put a 1 down there because I'm talking about seconds. So 1 minute is equal to how many seconds? Do you agree? That is 60 seconds. So this is what, I have 2 units here. I'm keeping the tweets up top and the seconds on the bottom. Okay, they have to be across from one another. Now from here, we're going to use, like I said, cross multiplication to solve it. So 10 times x, I'm just going to come over here, 10x, and then 60 times 7,500. That is going to land you at 450,000. And then your next step is to get x all by itself. This is 10 times x, so to undo multiplication, just divide by 10. You always divide by the number beside your letter. Those 10s cancel out. That leaves me with x on that side. Take this and divide it by 10, and I'm going to land then at 45,000 tweets would be sent in a minute. Final answer. Okay. All right, let's come on down then to example 9. In example 9, it says that Ted travels to 110 miles in 2 hours. We want to know then how long will it take him to travel 385 miles at that same rate? All right, so let's set up what we know here. He can travel 110 miles in 2 hours. So I'm putting my units on there. I can't stress enough how important it is, I think, for you to write those units, because then that helps you then come over here and you know then that miles have to be up top and hours on the bottom. Look at then what we know. We want to know how long it'll take him to travel 385 miles. So since we're given miles, that 385 this time is going to be up top, because that's where our miles are, and we don't know how many hours it's going to take. That's what we're trying to solve for. We're going to cross multiply again. So x times 110, that will be 110x equals 2 times 385, and that is going to put you at 770. When I get x all by itself, always divide by the number beside your letter. So I'm going to divide both sides by 110. Those 110s cancel out. Divide over here. You can always cross out zeros that they have in common, and 77 divided by 11 is just 7, or you could have put it in your calculator. Our x was hours, so this is 7 hours. So it would take him 7 hours to travel that 385 miles. Okay? All right, I hope this helps. Again, go back and finish up this set of notes. Make sure you've got a good handle on it. All right, thanks a lot. Bye.